The domain of F composed G. This is the set of all numbers in the domain of G such that G of these numbers are in the domain of F. If that seems a little confusing, don't worry about it. It is at first usually a little bit confusing, but that's the definition of the domain of F composed G. So suppose that this rectangle represents the domain of G, and you apply G to all the things in domain G, and you get the range of G. And so suppose the second rectangle here represents the range of G. So G takes the domain of G to the range of G. Now suppose the domain of F is here. Well, you're trying to do, for F composed G, you're trying to do G to X, to your value, and then F to the result. So you need to be able to do F, which means you need numbers that are in domain F. And then F will take domain F to range F. So you need to be able to get into this little intersection of range G and domain F. And those numbers there come from some subset of domain of G. So that little rectangle inside the larger rectangle, you have to be in there in order for F to be able to act on the values that G spits out, right? And then that will end up as some subset of range of F. It looks a little bit complicated. Usually we don't, for most math, especially in this course, we don't have to think about all these little details, but this is what is actually going on with the domain. So the domain of G composed F would be this small rectangle here, right? So okay, so let's go over that again. You're trying to do G, then F. If you do G and you end up over here, you can't take F of it because it's not in the domain of F. So I can only use the G's, the values in the domain of G that get mapped by G into domain of F. And of course it has to be in the range of G because every image of G of any value in domain G is in range of G. So then wherever this little box here goes, that's going to be the range of F composed G. And the domain is going to be this part here, this little box. So F composed G, it's that two island thing. The islands are these little rectangles, and you have to be able to do both hops. So I labeled the domain of F composed G and the range of F composed G. Okay, so this definition for domain F composed G is a bit complicated. So when we have formulas for F and G, we can find the domain of F composed G more simply, thank God, by just writing out the formula for F composed G of X, then finding the restrictions on X before simplifying. That's a key thing, before simplifying the expression. And then we can kind of ignore all this complicated stuff here, which is probably a good idea at this level of mathematics.